Right, and what is it? The 28th, isn't it? Okay, 128, 128:19. So the objective today is we're going to be looking at inverse relations and graphs. Okay. So what's an inverse of a graph? It's where all x and y values have been switched. Okay, what do I mean by that? So every point has some x, y, okay? Every point has some x, y, right? When you graph, you go, over 2, up 3, or whatever. Every point, to graph a point's got an x and y, right? Its inverse, and this is the symbol, this -1, okay? That's the symbol for inverse. That's my inverse symbol. Its inverse is just going to be yx. That's all we're going to do. So to find the inverse of a point, we just switch the x and y's. Do all functions have an inverse? No. We're going to see why. No. Okay. Now we're going to see why that doesn't work all the time. Okay, so first of all, example 1. So these are inputs. These are like x's. So you've got a 2 and a -1, a 0, 1, and a 2. And the outputs are -8, -6, -4, -2, and 0. Okay, we could graph it. We really could graph it. But what I'd rather do first is just take a look at its inverse. So its inverse, we're going to make the outputs be the inputs and the inputs be the outputs. I'll say it again. The outputs will become the inputs and the inputs become the outputs. So the inverse is going to look like this. It's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So -8, -6, -4, -2, 0 would pair up with -2, -1, 0, 1, and 2. These are now my inputs, or my x's, and these are going to be my outputs, or my y's. So all I did is I just switched. My x's became my y's, and my y's became my x's. Pretty easy, really. Okay, so what I want to do is graph these as points, and I'm going to try and use a couple of different colors, okay? So first of all, let's graph the first one, and I'm going to do it in purple, okay? So I'm going to think of these as points, all right? So I'm going to go -2, -8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, okay? And then I'm going to graph the point -1, -6. Okay? I'm going to graph the point 0, -4, 1, -2, and 2, 0, okay? Now I'm not going to connect the dots, even though you did, it's okay. I'm not going to connect the dots. I'm just going to leave them as points for right now. When I do the graphs, I definitely will connect those, okay? Now it's inverse. Let's see what the inverse does, okay? So the inverse is going to be switching the x and the y. So my new points would be, let's see, a -8, 1, 2, 3, 4, 5, 6, 7, 8, and -2, okay? And then -6, 1, 2, 3, 4, 5, 6, -1. -4, 0, -2, 1, and 0, 2. Okay? How am I doing? Now I want to make a couple of really important points about this, okay? First of all, if they are inverses, everything's going to be the opposite. So check it out. This y-intercept of 0, -4, this point right here of 0, -4 is a y-intercept. It becomes an x-intercept of the other. That makes sense, because they're opposites, aren't they? So I got an x-intercept here of -4, 0. This y-intercept becomes an x-intercept. this y-intercept of 0, 2 becomes a x-intercept of 2, 0. So if everything switches, if x's and y switches, then an x-intercept of 1 becomes the y-intercept of the other, or an x-intercept of 1 becomes the y-intercept of the other. It makes sense to me, okay? Now another thing happens, and that is they are a reflection of each other over a very special line. I'm going to draw that out up here, okay? So inverses are always going to be a reflection over this line right here. All right, let's see if that makes sense. Well, if I take, like a barbecue skewer, some kids can see this, and I fold it over this line. Do you see I'd fold over? The blues would fold right onto the purples, right? Or vice versa, the purples would fold a reflection. So inverse graphs, inverses, and their originals, I'm going to call it an original for right now, are reflections over the line y equals x, okay? So if I fold it over, it's right there, okay? Fold it over, so they're just reflections, okay? I also know that x-intercepts become y-intercepts, yeah. Y-intercepts become x-intercepts, yeah, because x's become y's, right? And y's become x's. Thumbs up? Do I see 2 thumbs up, 1 thumb up? How am I doing? Okay, good. This is pretty easy, right? This is easier than piecewise graph. You agree? All right? Okay, everybody ready for me to turn the page? Okay, no, wait for it, okay? And we'll turn it, okay? All right. Okay, now, example 2. Graph y equals a 1/2 x minus 2 and its inverse. Okay, well, I can do that. So let's see. I'm going to do this one in purple. So I'm going to start at -2. I'm going to go up 1, over 2, up 1, over 2. Okay, so forth and so on. So here's my line. I'm going to connect the dots now because I want a line, right? Right, Isaac?
Yeah.
So I'm going to actually connect my dots, okay? Now I need its inverse. So, all right, to get its inverse, I'm going to just switch some points. So to get the inverse, let's see. This is the point 0, -2, right? 0, -2. This is the point 2, -1. This is the point 4, 0, right? So if I want its inverse, I'm just going to switch the points and graph the line. Okay? I'm going to switch the points. So the points I need now are going to be, let's see, I'm going to need a -2, 0. I'm going to need a -1, 2, and I'm going to need a 0, 4, right? So just switch. So switch the points. Switch the points, right? So let's see. I'm going to graph a -2, 0 is there. A -1, 2 is there. And a 0, 4 is there. And I should be able to graph my line right in there. Okay? All right, so what's that equation? What's the equation of the inverse? Well, let's see. I'm going to use my y equals mx plus b for the equation of the inverse, right? So I'm going to say, let's see, y equals, let's see, it's up 2 over 1. I'm going to go 2 over 1x plus 4, okay? So here's my inverse equation. And I just got it from graphing it and going up 2 over 3, okay, up 2 over 3. Now, that's the hard way to do it. It works, okay? On a test or quiz, and I ask you to graph an inverse, this will always work, okay? Get some points, switch them around, and graph it. Easy. But that, to me, is the hard way to do it, to me. The easy way to do it is to switch, you ready? We're going to switch x and y, so you guys with me? Why don't we switch them all at once? Why don't we switch all of the x's and all of the y's all at once? How do I do that? Let's switch the variables. Okay? F of x and y are the same thing, right? We talked about that. F of x, we'll note, we know that f of x and y for us in this class is always going to be the same. You won't see anything but f of x and y being the same thing in here. Algebra 2, we'll switch it up on, okay? So I'm going to rewrite this as y equals, 3x minus 12. Okay. Now, if I need its inverse equation, so if I want the inverse equation, here's what I want to do. I want the inverse equation. I am going to, little star, switch x and y. Because if I switch x and y, I've switched every single x, every single y, because x represents all of the x variable, all the x values, and y represents. So I'm just going to rewrite this as x equals 3y minus 12. Boom. That's all I did. Just switched them. X becomes y, y becomes x. That's all I did. Okay? Now, to graph this, we need to solve for y. Okay, now, then solve for y. Okay, I can do that. If I want to solve for y, how do I solve for y? Let's add 12 first, but we're going to. Yes, but let's add 12 first. Okay, plus 12 plus 12, plus 12 plus 12. We're going to go on x plus 12 equals 3y. You guys okay with that? I just, plus 12 plus 12. I'm going to put a 1 here, because I'm going to put a 1x, put a 1 right there. Okay, now what are we going to do? Max? Divide by 3. Let's divide everything by 3. Max, you were not wrong to divide by 3. It's just easier to do it as the second step. It would have worked, by the way. So you were right. How does that make you feel? You were right. Just easier to do it at this step, okay? So now, here's my inverse. Y equals 1/3 x plus 4. Okay? Now, almost done. So, if I go, and I'm going to flip the page for a second, real quick. No, wait, I'm going to flip the page in just a second. So if I flip the page back, remember this little symbol here? That means inverse, doesn't it? Okay, so I'm going to flip it back. So real quickly, this is a function, right? I know it's function, start at 4, up 1 over 3. This is a function. You guys agree? It is a function. Yes, it's a function. Okay? So I'm going to rewrite it like this. F inverse of x equals 1/3 x plus 4. Now let me highlight two things so you can see it. Okay? Okay? Take a look at the two things I circled. Here's my function. That's my original. Does that make sense? That's my original. It says f of x. And that, I know that's my inverse because I put that little symbol there, right? By putting out f -1, here's my inverse. And here's my function, here's my original, and here's my inverse. So that little -1 tells me that that's the inverse, okay? Thumbs up? Okay, let's get our journals out, because there's some other stuff in our journals that might be a little weird, okay?